Okay, students, I'm going to try to help you out with a couple of these parallelogram problems. I have just a general parallelogram, and I'm going to actually use some of the information that appears in your book. This is on page 229, number 4. The diagram doesn't look exactly like this, but what you do have is you do have an angle on this side that was marked to be 3x minus 20. And you have an angle on the opposite side that was marked to be 4y. And you had an angle up here that was marked to be x plus 40. Okay. Now, for all of these parallelogram problems, what you are going to end up doing a lot of times is not just setting up one, but a lot of times setting up two different equations. Now, one thing you need to know is whether or not it's talking about a side or an angle. And I can tell each of those are an angle because in the book they have a little degree symbol by the measure. If the problem or the book is being accurate, anytime it is an angle measure, it's going to have a degree. So I've got a 3x minus 20 degrees, 4y degrees, and a x plus 40 degrees. Now, there's basically two things that are true for the parallelograms we have seen so far. I'm either going to be looking for things that are equal or things that add to a certain amount. So my first question is, am I looking for things that are equal or things that add to a certain amount? Well, one of the properties of a parallelogram is that opposite angles are equal. So this angle here, the 3x minus 20, is equal to the angle that is opposite or across from it, which is 4y. When I set up that equation, it's not particularly useful because I have two variables and I don't have enough information to solve. Fortunately, I have another equation, though, because I have this x plus 40, which is over in this part of my graph. Sorry, I kind of moved the parallelogram accidentally. And then what I can do is I can take this angle right here, my x plus 40, and say it is adjacent to this. Adjacent means next to. So this angle here I'm marking in blue, and this other angle here I'm marking in blue are adjacent. They are next to each other. So what I'm going to say is I have a 3x minus 20. Since it is adjacent to the x plus 40, if I add those two together, they should be equal to 180 degrees. For sake of space, I'm going to write my 180 degrees over on this side for the time being. So they are not equal, but they are adjacent. So that means they're supplementary, adding to 180. It is true that anytime you have a large angle and a small angle in a parallelogram, they are going to add up to be 180 degrees. You notice this angle here is acute. This angle here is obtuse. So anytime I have an acute or an obtuse angle around parallel lines, they are supplementary, adding to 180. I'm going to simplify this equation. Since it only has one variable, I can solve it. So that gives me a 4x plus 20 equals 180. And then that gives me a 160 equals 4x. And then by subtracting 20 from both sides. And then if I divide by 4, I will get my final answer that x is equal to 40. So that tells me what x is, but it does not take care of y, and I needed to solve for both variables. So what I'm going to do now is I'm going to say, well, I know what x is. To find out what y is, I'm going to take this 40 degrees and substitute it all the way over here where x is. So that means I'm going to have 3 times 40 minus 20 equals 4y. By substituting in for x, I've gotten rid of one of my variables, so I can simplify now. 120 minus 20, which turns out to be 100, is equal to 4y. So I divide by 4, and my answer here is y equals 25. So you can see we were able to solve for both variables by writing two separate equations and then finding the one we were able to solve first and using that solution to substitute in and solve for the other equation. And once again, this is a lot like problem number 4 on page 229. I hope this is helpful to you.